Right, so this is unit 2. We're going to look at functions. This unit is called functions. Um, and so first thing, before we talk about functions, we're going to talk about what is a relation. We can think of relation as any set of ordered pairs, where you can say that x is paired with a y, okay? You can think of it on a coordinate plane. So for example, this point right here, you have an x value, you have a y value. So that there is a relation. Not just one point, you can have many points, something like that. A function is a special type of relationship, okay, where each input has single output, okay? So what is an input and an output? We'll talk about that later, but this basically, each x value has exactly one y value. So x cannot go to multiple different y values. It can only go to one y value. In other words, a function has no set of repeating x values, okay? Repeating x. Some other vocabulary is the word domain. Domains is the input, while the range is the output, which you're plugging in and what you're getting out. Domain is also your x values, while the range are your y values. And the other thing is domain is the independent variable, meaning it doesn't depend on anything, while the y value depends on the x value. So this is a dependent variable. Okay. All right. So here's some ways we can express relations. So just how do we write them out? So here we have the domain of 0, 1, 2, and 6, range of 3, 3, 4, and 5. So we can write these as an ordered pair here. We can just put the domain goes to from 0, and I'll just pick one here. Doesn't specifically tell me when I write it like this which goes with which, so I'm just gonna just pair them up as much as I could. 2 goes to 4 maybe, and then 6 goes to 5. They could be kind of switched around a bit. You can write this as a table. So you have your x values and your y values. So 0, 1, 2, and 6. Go to 3, 3, 4, and 5. And we can also graph them. So 0, x is 0, y is 3, x is 1, y is 3, x is 2, y is 4, x is 6, y is 5, something like that. Okay. Same thing here. We can just take some ordered pairs here. -2 can go to 1. -1 can go to 2 or 3. Doesn't matter really. It matters when you specifically know on a graph or a table. In this case, there's really no way to know which goes to what. And then you can even have them go to multiple different numbers. So table is the same and ordered pairs is the same. I'll skip this one for now. We can look at that. So here's some other ways we can look at to see if a relation that's given is a function or not. Okay, ways to see if this relation is a function. Remember that the function will never have repeating values in the domain. Basically, no repeating x. So here's some ordered pairs I have here. Example 1 has 2, 3, 4, and 2. Look at this, 2 and 2. It's repeating. So that is not a function. Example 1 is not a function. Let's look at example 1. Example 2, maybe it is a function. 4, -9, 0, and 3. Yes, it is a function. Only because the x value is not repeating. This one is not a function. This one is, yes, a function because the x values are not repeating. Here, when you have a graph, we can do the vertical line test. So you can see that each vertical line is only hitting it once, so which means that another way to clearly see that the x values are not repeating. So this is a yes, that is a function. This one, no, is hitting it twice right there. So this is a no, no, no. Here, input is 10, is going to 15, 20 is going to something else. So this is not yes, a function, because the x values are now repeating. But look at this one. 2 is going to 20, and 2 is also going to 40. So this is not a function. Okay. So here's some examples for you to try. You just have to look at the x value and see if it's repeating or not. There's just a bunch of examples here. So go ahead and do the next 2 pages as just a practice for this lesson. Okay.